region is between from A to B. So elastic behavior, it will show between A to B, this area of the graph, this portion of the graph. Plastic region is denoted by C, and Hooke's law is also obeyed in this area of the graph. So 7 is A, 8 is C, and 9 is again A. So the initial portion of the stress strain curve region corresponds to elastic deformation, the region within which stress is proportional to strain and the material obey Hooke's law. Beyond point B, the material deforms plastically. So we already discussed all these things. So now next, in this figure we have to show a few, here are a few curves are here. So the figure on the left is a histogram of Young's modulus of a series of materials, while the figure on the right depicts schematic stress strain curves for tungsten, rubber, diamond, quartz and molybdenum. Select the letters A, B, C, D or E to indicate which stress strain curve corresponds to quartz, molybdenum and tungsten. So ये A, B, C, D, E ये जो curves हैं, ये हमें इनमें से बताना ये है कि क्वार्ट्स का कौन सा है, मॉलिब्डेनम का कौन सा और टंगस्टन का कौन सा है. सो जस्ट सी हियर, होता क्या है, द मटेरियल्स इन द डिक्रीजिंग ऑर्डर फॉर यंग्स मॉडुलस आर. सो सबसे ज़्यादा यंग्स मॉडुलस की वैल्यू डायमंड की होगी, फिर टंगस्टन की, देन मॉलिब्डेनम, देन क्वार्ट्ज एंड देन रबर. Because the initial slope of the stress strain curve is numerically equal to Young's modulus, each stress strain curve can be associated with one of the materials. So such that E is diamond, D is tungsten, C is molybdenum, B is quartz and A is rubber. So जो E curve है that represents diamond, D represents tungsten, C represents molybdenum, B quartz and A rubber. So B represents quartz, B represents quartz, D represents molybdenum and E represents tungsten. So the answer to the question is B, C and D. B, C and D. Now next let's start next we are going to solve few problems on surface tension. So surface tension, let's quickly define what is surface tension. Surface tension is a phenomena in which the surface of a liquid, where the liquid is in contact with gas, acts like a thin elastic sheet. So this term is typically used only when the liquid surface is in contact with gas. If the surface is between two liquids, it is called interface. So how to calculate surface tension? Surface tension, this is denoted by gamma and this is given as force per unit length. So T or gamma, this is the symbol for surface tension and it is given as force per unit length. So surface tension is measured, इसके units हो गए Newton upon meter or sometimes in CGS system it is Dyne upon centimeter. So in order to consider the thermodynamics of the situation, it is sometimes useful to consider it in terms of work per unit area. So work per unit area, so ऐसा ही इसके units हो जाएंगे joule upon meter square और जो CGS हो जाएंगे वो हो जाएंगे erg upon centimeter square. Work is measured in joule, area is measured in meters. So surface tension, either this is its unit can be Newton upon meter or it can be joule upon meter square. So now this formula, this is formula for rise of liquid in this capillary tube, this height h. So we call this formula as ascent formula. So this ascent formula, this is rise of liquid in capillary tube, h, this is given as 2T upon rho Rg, where T is surface tension, rho is density of the liquid, R is radius of the tube and G is acceleration due to gravity. So these formulae we will use to calculate, solve few problems. So next let's start with the problem. A soap bubble 50 mm in diameter contains a pressure in excess of atmosphere of 2 bar. Find the surface tension in the soap film. So given क्या क्या है, radius is given, this is 25 mm, so this is 0.025 meter. Then delta P, pressure is given, So this is 2 bar, this is 2 into 10 power 5 Newton upon meter square. So formula जो use होगा, pressure inside a soap bubble and surface tension sigma are related by delta P is 4 sigma upon R. हमें sigma निकालना है. Sigma is surface tension. So this sigma, this is given as delta P R by 4. Delta P is pressure change. R, what is R? This is radius of the soap bubble. So these values are given. Substituting the value, pressure is 2 into 10 power 5, radius is 0.025. So divided by 4. इसको solve करने के बाद surface tension sigma, this comes out to be 1250. So 1250 Newton upon meter. So this is the value of surface tension in the soap film. Next, another example is, air is introduced to a nozzle into a tank of water to form a stream of bubbles. If the bubbles are intended to have a diameter of 2 mm, calculate how much the pressure of the air at the tip of nozzle must exceed that of the surrounding water. Assume that the value of surface tension between air and water as 72.7 into 10 raised to the minus 3 Newton upon meter. So solution is given, क्या क्या है हमें, surface tension sigma is given, radius of the bubble r is given, formula use होगा again the same formula, delta P is 2 sigma upon r. So sigma is given, r is given, now we have to find the delta P. So delta P, this is 2 into 72.7 into 10 to the minus 3 divided by 1. Calculating this, the pressure comes out to be 145.4 Newton upon meter square. Another problem, water has a surface tension of 0.4 Newton upon meter. In a 3 mm diameter vertical tube, if the liquid rises 6 mm above the liquid inside the tube, calculate the contact angle. So here we have to find contact angle. Given is surface tension sigma, diameter of the tube is given, and rise of the liquid, that is height, is given. Capillary rise height h is given 6 mm, that is 0.006 meter. So formula used will be that of capillary rise, that is ascent formula. So h is 4 sigma cos theta divided by rho gd. Rho is density, g is acceleration due to gravity. So substituting the values, cos theta, take out cos theta को इसमें से बाहर निकाल लो फॉर्मूले में से, because we have to find cos theta. So cos theta is h rho g d divided by 4 sigma. Sigma is surface tension. So substituting all the values, h is height, rho is density, g is acceleration due to gravity, d is diameter. So we are putting all these values, theta comes out to be 83.7 degree. So this is the angle of contact angle. Now next problem is, two soap bubbles A and B are obtained at the ends of a glass tube with a stopcock at its middle. So the stopcock is closed initially and the bubble B is larger in size. If the stopcock is opened, what happens to the bubbles? Number 1, nothing will happen. Number 2 is the size of A decreases and the size of B increases. C option is the size of A increases and size of B decreases. D option is both A and B will decrease in size. E option is both A and B will increase in size. Now let's see what happens. The excess pressure inside the smaller bubble A is greater and hence air from it will rush to B through the tube. The size of A will decrease further while the size of B will increase. So the correct option is B. The size of A will decrease further and the size of B will increase. So the answer option B is right. Another problem, a tall metallic jar has a small hole of radius 0.07 mm at its bottom. So what is the approximate depth up to which the jar can be lowered vertically in water before any water penetrates into it through the hole? Surface tension of water, this is 0.073 Newton upon meter. Options A 7 cm, B 11, C 16, D 21 and E is 27. So let's see the solution. What is the solution of this problem? Water will begin to enter the jar through the hole when the hydrostatic pressure exceeds the allowed excess pressure of 2T upon R on the concave side of the water surface at the hole. Therefore, the depth h up to which the jar can be lowered safely is given by HdG is 2T by R, so that H is 2T divided by dgr. Substituting these values, T tension, D density, G acceleration due to gravity and R radius, this height, this comes out to be 21 centimeter. So the answer solution is 21 centimeter. If T is the surface tension of a soap solution, the amount of work done increasing the radius of a soap bubble from R to 2R is. So T is surface tension, amount of work done in increasing the radius of a soap bubble to R to 2R is. 4 options are given. So just see what is the solution. Work done, this is increase in surface area into T. So what will be work done? Increase in surface area into T. So increase in surface area क्या हो जाएगा? हमें रेडियस को इंक्रीज करना फ्रॉम R to 2R. So this is 4 pi into 2R square minus 4 pi R square multiply by T. So this comes out to 24 pi R square. So the correct option, the answer is C. Note that the bubble has two surfaces. So it has two surfaces, that's why we have multiplied this with 2. So work done, this will be increase in surface area multiplied by surface tension. Using this formula, the right option comes out to be C. Next, water rises in a capillary tube to a height h. Choose false statement regarding capillary rise from the following. A option, on the surface of Jupiter height will be less than h. B option, in a lift moving up with a constant acceleration height is less than h. C option, on the surface of moon height is more than h. D option, in a lift moving down with a constant acceleration height is less than h. At poles height is less than that at equator. So we have to choose the false one out of these 5, which is the false one. So the solution is the expression for surface tension T in terms of capillary rise. This is given by this formula. This is the sand formula only, where h is the capillary rise, r is the radius of the tube, d is the density of the liquid, g is the acceleration due to gravity, and theta is the angle of contact. So when g is less, the capillary rise h is more. So the answer lies in this point, that when g is less, when g acceleration due to gravity कम होगा तो capillary rise ज़्यादा होगा. So value of g is smaller in option C and D, only so that the value of h is greater in these two cases. So the option D is false. Note that when a lift moves down with acceleration a, the effective value of acceleration due to gravity is g minus a. So the answer lies in, when g is less, the capillary rise h is more. g कम होगा तो capillary rise ज़्यादा होगा. So here the right option is D. Now quickly we will go through few problems on pressure. So what is pressure? Pressure is defined as force upon area. So force upon area is pressure. And what is atmospheric pressure? Atmospheric pressure refers to the pressure prevailing in the atmosphere. So it varies somewhat with changing weather conditions and it decreases with increasing altitude. Height बढ़ने पे, ऊपर जाने पे atmospheric pressure कम हो जाता है. And at sea level, atmospheric pressure की value, this is 101.3 kilopascal, or we also name this as 1 atmospheric pressure. So this is commonly referred to as standard atmospheric pressure. So pressure calculate करने के लिए, अगर एक तो हो गया force upon area pressure का formula, but for a liquid in open tank, जो फॉर्मूला यूज़ होगा प्रेशर कैलकुलेट करने के लिए, P विल बी H रो G. H इज़ हाइट ऑफ द लिक्विड इन द टैंक, रो इज़ डेंसिटी ऑफ द लिक्विड and G is acceleration due to gravity. So what is absolute pressure? When measuring the tire pressure, you measure pressure above atmospheric pressure. So recommended pressures for tires are gauge pressure. Absolute pressure is the total pressure of all gases including the atmosphere. So what is absolute pressure? This is the total pressure including all atmosphere. So question is, how would you figure it for an inflated tire? So answer is add barometric pressure to the gauge pressure. So एक inflated tire के लिए what is absolute pressure? So this will be gauge pressure plus the barometric or the atmospheric pressure. So what is gauge pressure? How you can calculate gauge pressure? Gauge pressure, what the gauges measure. So this is given as P minus P atmospheric pressure. So using this formula we can find the value of gauge pressures. So gauge pressure, this is the pressure measured above or below the atmospheric pressure. This can be positive or negative. Absolute pressure uses zero. Absolute means we start from the zero, so which is the lowest possible pressure. Therefore an absolute pressure will always be positive. A simple equation relating the two pressures measuring, this can be written as absolute pressure. This is gauge pressure plus atmospheric pressure. So P absolute is P gauge plus P atmospheric pressure. So with this I conclude my today's lecture. Hope all of you enjoyed. Thank you.